Beneath our feet lies a world of complexity and mystery, a realm unseen by most, yet fundamental to the very nature of our planet. The Earth's internal structure is a marvel of layered architecture, each stratum playing its part in shaping the world above. To truly appreciate the ground we walk on, let us embark on a journey, much like the imaginative adventure penned by Jules Verne in Journey to the Center of the Earth, and descend, layer by layer, through Earth's dynamic interior. Our journey begins at the surface, where life flourishes in all its diversity. This outermost shell is called the crust. Though it sustains all terrestrial existence, the crust is astonishingly thin when compared to the planet's vast size. Like the skin of an apple, it is delicate and fragile. The continental crust, which forms the landmasses, extends down to about 35 kilometers, just over 20 miles, while the oceanic crust, forming the seafloor, is even thinner, ranging from 5 to 7 kilometers. The crust's composition is primarily silicate minerals, and it is divided into tectonic plates, which drift ever so slowly atop the underlying mantle. These plates are the driving force behind earthquakes, mountain formation, and volcanic eruptions, constantly reshaping our world in an ongoing geological dance. Passing through the crust, we enter the upper mantle. Here, the environment shifts dramatically. Temperatures and pressures increase, and the rock, though still solid, becomes capable of flowing over long periods. This upper mantle extends from the base of the crust down to about 660 kilometers. It encompasses the asthenosphere, a semi-molten ductile region that behaves much like hot wax. It is within the asthenosphere that convection currents form, as heat from deeper within the Earth causes the rock to move in slow, churning cycles. These currents act as conveyor belts, carrying tectonic plates above and powering the restless activity of the surface. Deeper still, from 660 kilometers down to nearly 2,900 kilometers, lies the lower mantle. The immense pressure here prevents the rock from melting, so, despite temperatures soaring to thousands of degrees Celsius, the lower mantle remains solid, though the rock is much denser and flows even more slowly than above. The heat and pressure combine to create a zone where minerals are compressed into new forms, and seismic waves move differently, providing scientists with clues about the mantle's composition and behavior. Now, we approach a dramatic boundary known as the core mantle boundary. At this depth, nearly 2,900 kilometers beneath the surface, we enter the Earth's outer core. Here, everything changes. The solid rock of the mantle gives way to a vast ocean of molten metal, primarily iron and nickel. Temperatures here range from about 4,000 to 6,000 degrees Celsius, and the pressure is immense. Yet, it is not enough to solidify the metal, which remains in a liquid state. This churning, convecting sea of liquid metal is of profound importance. It generates our planet's magnetic field, a shield that protects the biosphere from harmful cosmic radiation and guides migratory animals across continents and oceans. Descending further, to a depth of about 5,150 kilometers, we reach the innermost sanctum, the inner core. Despite temperatures rivaling those found at the surface of the Sun, the pressure here is so extreme that iron and nickel are compressed into a solid state. The inner core is a sphere about 1,200 kilometers in radius, a dense, unyielding ball of metal. It is the hottest region of our planet, reaching temperatures up to 5,700 degrees Celsius. The solid inner core slowly grows over time, as the Earth cools and the outer core's liquid iron crystallizes onto the inner core's surface. To remember this remarkable structure, one might recall a simple mnemonic. Cool men often ignore lava. Each word stands for a layer: crust, mantle, outer core, inner core, with lava serving as a reminder of the heat and volcanic activity that connects us to Earth's deeper regions. But the scientific understanding of these layers is a relatively recent development. For centuries, humans have speculated about what lies beneath the surface. Myths and legends abounded, of fiery underworlds, hidden realms, and vast subterranean oceans. It was in this spirit of curiosity and wonder that Jules Verne wrote Journey to the Center of the Earth, a novel that captivated readers with its imaginative exploration of the world below. In Verne's story, the protagonists descend through a volcanic crater in Iceland, embarking on a fantastical odyssey through immense caverns, ancient seas, and landscapes inhabited by prehistoric monsters. Though his vision was not rooted in geology as we know it today, Verne's tale sparked generations of scientific inquiry and adventure. Modern science paints a different, yet no less fascinating picture. The crust is not a uniform shell, but a patchwork of plates, moving ever so slowly atop the semi-fluid asthenosphere. Subduction zones, where one plate dives beneath another, recycle crustal material back into the mantle, while mid-ocean ridges create new crust as molten rock rises and solidifies. This ceaseless cycle drives the formation of continents, mountains, and ocean basins, shaping the face of the planet over millions of years. Within the mantle, the slow movement of rock drives not only the surface plates, but also the transfer of heat from the planet's interior to its surface. Mantle plumes, columns of hot, buoyant rock, rise from deep within, occasionally breaking through the crust to form volcanic hotspots like those of Hawaii and Yellowstone. These plumes are windows into the deep earth, revealing processes that have shaped our planet since its formation. The boundary between the mantle and the core is a region of intense scientific interest. Known as the D layer, it is a place of complex interactions, where seismic waves slow and bend, hinting at chemical reactions, temperature changes, and perhaps even pockets of partially molten rock. It is here that the solid silicate mantle meets the liquid metal of the outer core, a transition as profound as any on Earth. The outer core, swirling and churning, is the engine of Earth's magnetism. As the molten iron and nickel move, they generate electrical currents, which in turn produce a magnetic field extending far into space. This field shields the planet from the solar wind, preserving the atmosphere and enabling life to thrive. The outer core's movement is influenced by the rotation of the Earth and the gradual cooling of the planet, creating a dynamic system that has endured for billions of years. At the heart of it all, the inner core remains a subject of intrigue. Recent research suggests that it may rotate at a slightly different rate than the rest of the planet, and that it is not a homogeneous sphere, but may contain regions of differing composition and structure. Each year, as the Earth cools, the inner core grows by a few millimeters, a slow but relentless process that will continue for eons. Despite the immense challenges, scientists have developed ingenious ways to study these hidden layers. By analyzing the way seismic waves from earthquakes travel through the Earth, researchers can infer the properties and boundaries of each layer. Laboratory experiments recreate the high pressures and temperatures found deep within, revealing how rocks and metals behave under such extreme conditions. Satellites monitor the magnetic field, providing clues to the movements within the outer core. And so, as we stand on the solid ground of the crust, we are supported by a vast and active interior, a world of rock and metal, heat and motion, mystery and discovery. The journey to the center of the Earth, though impossible in the literal sense, is one we undertake through science, imagination, and the enduring human quest to understand our planet. From the cool crust to the blazing inner core, the Earth's layers are a testament to the planet's dynamic nature and its ongoing evolution. The story of Earth's interior is not just about rocks and metals, but about the processes that make life possible, the forces that shape continents, and the mysteries that continue to inspire exploration, both real and imagined.